Alrighty, so we went ahead and dealt with a situation where Bob is saving money over the summer. He has a summer job where he makes $20 every hour. However, before he started working, he saved $40 in his bank account that he opened. So let's go ahead and make a table that represents that information. And we will be able to tell, how do you know a table represents a non-proportional relationship? If you recall, graphs, they represent non-proportional relationships if you have a straight line, but that line does not start at zero. An equation represents a non-proportional relationship if it's in the form of y equals mx plus b, where m is your slope and b is your y-intercept. So what about tables here? How do we know a table represents a non-proportional relationship? There's two more things we want to look out for. So let's go ahead and get started. Let's graph that information of Bob and the money he saved versus the hours he worked. If you recall, our x-axis was hours worked, our y-axis was money saved. So remember, he had 40 already saved, so at 0 hours he had already had 40 in his bank account. And he is making for $20 every hour. So at 1 hour, he makes $20, but he already had 40 saved, so 40 plus 20 would be 60. At 2 hours, he makes 20 more. 60 plus 20 is 80. At 3 hours, he makes 20 more. 80 plus 20 is 100. At 4 hours, 20 more, which is 120. 5 hours, 20 more, which is going to be 140, and that's where we'll stop for now. So let's go ahead and look to see what is our change in our y values and our change in our x values. So what are we increasing by every time in the x values? It looks like every time we are increasing by 1. Each time down we are increasing by 1 hour. He's working 1 hour increments, or he gets paid per hour. And what about y values? It looks like he is getting paid in $20 increments. So we've got plus 20 down this table. We've got plus 20 down the table. So if you look close, what are our change in y values every time? Our change in y values every time is going to be plus 20. What is our change in x values every time? The change in x values is going to be plus 1. So it looks like the change in x and y is constant. The change in x and y is constant. We'll make note of that up here. The change in x and y is constant. And constant meaning it's the same throughout. As we go down the table, the changes are the same. What about, we need to check our y variables divided by our x variables. So just like how we find slope and we say slope is calculated by calculating the rise over the run, we want to calculate the y values divided by the x. Remember, rise is vertical axis, run is x axis. So rise divided by run, we want to calculate the y divided by the x. So what's 40 divided by 0? Let's go ahead and check all our y's divided by our x's. 40 divided by 0, that's actually going to be undefined. You can't divide anything by 0. So that's going to be undefined. Let's keep going down the table. Our y's divided by our x's. This will be 60 divided by 1, which is just 60. Let's keep it going. Y divided by x. 80 divided by 2, which is 40. Y divided by x. 100 divided by 3, which isn't going to be an even number. It's going to be 33.3 33.3 repeating. 33.33333. Let's keep it going. 120 divided by 4, which is going to be 30. And then 140 divided by 5, which is also going to get us some decimal number. So let's go ahead and look down this table. If you recall, in proportional relationships, if the ratio of y divided by x was always constant, was the same as we look down our table, then this would be a proportional relationship. It is a proportional relationship. However, look at the ratio of y to x as we look down the table. We got undefined, we have 60, we have 40, we have 33.3, 30, and so on. The ratio of y to x is not constant. There, we do not get the same result as we look down this ratio of y to x. So the ratio of y to x is not constant. The ratio of y divided by x is not constant. So this is the same information that we graphed that we said represented a non-proportional relationship in a graph. And so we brought this information to a table and we came up with these two things. The change in y and x are definitely constant as we look down this table in each column. The change in y is always 20. The change in x is always 1. What else did we get from this situation? We got that the ratio of y divided by x, y divided by x, y divided by x, and so on is not constant. We have different results every single time. So how do you know a table represents a non-proportional relationship? The change in y and x is constant. However, the ratio of y divided by x is not constant.